The problem is range MEX. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an array A of n non-negative integers. In one move, we can do the following. We can choose a range L and R such that both of them are between 1 and length of our array. Then we'll make x as the MEX of the range that we have chosen. MEX is nothing but the smallest non-negative integer that is not present in the range, and then we'll insert this x back into A in any position that we want. Now given an integer k, we need to find the minimum moves needed to insert k into the array. Note that you need to do this even if array already contains k. MEX, as we have discussed, is the smallest non-negative integer not present in A. For the input format, we have t test cases, and for each test case, we have two lines. The first line contains the integer n and k, and the second line contains n spaced integers. Those are a1, a2, a3 till an. As for the output format, we simply have to output the minimum moves needed to insert k into the array. As for the constraints, number of test cases will go from 1 to 10 raised to 4, length of the array will go from 2 to 10 raised to 5, and the value of k and element will be within n. Let's see some sample input. So for the first sample input, there are 3 elements given to us, and we need to find out in how many terms are we going to able to insert k, that is 2 here. The array with us is 0, 1 and 0. Now if you see, the MEX here, the smallest non-negative number that is not present is 2 itself. So within the first step, we have to insert 2 here. Therefore, the answer is 1. Let's see the second sample. Here, our n is equal to 4 and k is also 4. The array that we have with us is 0, 2, 2 and 0. Again, the MEX of the complete array currently is 1. So we'll have to insert 1. Once this is done, we'll check now what is the MEX. Now we have 0, 1 and 2. The now MEX is 3. And at the end, now the MEX becomes 4. So it is at the third step, the third insertion, that we were able to insert k here. Therefore, the answer is 3. As for the final sample input, the value of n is 3, the value of k is 2, and the array that we have is 2, 3 and 2. Right? So now, we cannot choose a subarray that already has k, because if we choose that, we will not be able to insert k into it, because even if we are able to insert k minus 1, once that is inserted, the value of MEX will simply jump to k plus 1 and we will not be able to insert k there. Therefore, we cannot choose a subarray that already has k in it. So what we'll do is, we'll choose this. The MEX here is 0, then it will become 1, and finally it will become 2. So again, at the third step, we were able to insert 3. Therefore, the answer here is 3 as well. Let's see how we can approach the solution. Let's first do it for the array A that does not contain k. In that case, the complete array that we have will not have the element k in it. Now if you want to insert k, we need to make sure that all the elements going from 0, 1, 2 till k minus 1 are already inserted. Only then are we going to able to insert k here. So from 0 to k minus 1, we have k elements, and the kth element itself is one more element. So in total, there are k plus 1 elements. Now, it's not that we don't have any elements available here, right? We already have some elements, and we are assuming that k is not here. So in that case, we will check what are the other distinct numbers that we already have, because we don't need to add them. We only need to add those that are missing. We'll find, let's say there are d distinct elements. So whatever is the difference are the number of elements that we need to add so that we can reach k and add it. So for an array where we don't have k in it, our answer is nothing but k plus 1 minus d, where d is the number of distinct elements that are less than k. Now what happens if our array already has k? So it could look something like this. Let's say we have k here, then we have some other elements, and we have one more k. Now as we have seen, we cannot touch or we cannot include k into our subarray, because if we do, then we will not be able to insert k in it. So now the problem simply breaks down into subarrays. So we can do the same thing that we did above, but now here for the smaller subarrays. Let's say the value or the number of terms that we can insert k here, we get there in x, here we get there in y, and so on and so forth. We simply have to take whichever is the minimum. And with that, we will get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n, k, and then our array. Now once we have our array, what we are going to do is, we are going to keep on adding elements into another array until we reach k element. That is, until we have an element whose value is k, we will keep on adding elements into another array. Once we reach k, we will find the number of distinct elements in this array that are less than k, and we will get a local answer, that is nothing but the number of terms needed to add so that we can add k into it. If there are no k into our array, we'll simply add all the elements into b and finally find out what are the number of terms that we need to add here. But if that is not the case, we keep on calculating the local answers and we take whatever is the minimum. At the end, we print it, and as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take input of n, k, and then our array. Then we start finding our answers. That is, we keep on adding elements to another array until we reach k. Once we have this array that does not have any k elements, we find out the number of elements that we need to add so that we can add k. We keep on finding these local answers, and at the end, we take the minimum of it. And as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.